Good morning, students. இன்னைக்கு நம்ம பார்க்க போகிறது Ist B.Sc Chemistry general chemistry பார்க்க போகிறோம். General chemistryல இன்னைக்கு ஃபர்ஸ்ட் வந்து ionization potential, electron affinity, electronegativity இதை பற்றி நம்ம பார்க்க போகிறோம். First பார்த்தீங்கன்னா ionization potential. Ionization potential என்னன்னா the ionization potential is the energy required to remove an electron from the isolated gaseous atom to form a positive ion. Ionization potential is the energy required to remove an electron from an isolated gas atom to form a positive ion. Isolated gas atom ஆட்டத்திலிருந்து ஒரு எலக்ட்ரானை பிரிச்சு எடுக்கிறதுக்காக ஒரு எனர்ஜி தேவைப்படுது. இந்த எனர்ஜி தான் வந்து அயனைசேஷன் பொட்டன்ஷியல் சொன்னாங்க. இந்த அயனைசேஷன் பொட்டன்ஷியல் எனர்ஜியை வந்து ஒரு சில ஃபேக்டர்ஸ்லாம் அஃபெக்ட் பண்ணுது. அதுதான் பார்க்க போறோம். ஃபேக்டர்ஸ் அஃபெக்டிங் தி அயனைசேஷன் பொட்டன்ஷியல். ஃபர்ஸ்ட் வந்து எஃபெக்டிவ் நியூக்ளியர் சார்ஜ் அண்ட் ஸ்டேட் ஆஃப் தி ஆட்டம். அடுத்தது வந்து பிரின்சிபல் குவாண்டம் நம்பர். அடுத்தது வந்து ஷீல்டிங் எஃபெக்ட், half filled and completely filled orbital, natural of orbitals and octet arrangement. இதெல்லாம் வந்து factors affecting the ionization potential வருது. இதுல first வந்து effective nuclear charge பார்ப்போம். Greater the magnitude of the effective nuclear charge, higher is the ionization potential need to remove their outermost shell electron. Thus moving from left to right in the period, the effective nuclear charge increase, so ionization potential also increase from left to right. State of the atom. Higher size of an atom or for radius, lower will be its ionization energy. Thus, as we remove down a group, the value of radius, the atomic radius increases. Then, principal quantum number. The magnitude of the ionization potential decrease with an increase in the value of the principal quantum number n of the orbital from which electron to be removed. This factor is also used to explain the variation of ionization potential of elements in a group. As we move down a group, the value of principal quantum number n of the orbital form which the electron is to remove increases. So the ionization potential also decreases. Next one is shielding effect. In a multi-electron atom, the electron lying between the nucleus and valence shell or intervention electron. These electrons shield the outermost shell electron from the nucleus. This is called a shielding effect or screening effect. Next one is half-filled and completely filled orbital. Half-filled and completely filled orbitals are more stable than partially orbital. Thus, elements having NS2, NP3, NP6, ND5, ND10, etc. configuration are more stable than the element having other configuration. So the ionization potential of an atom having half-filled or completely filled orbital in its electronic configuration will be more than that expected normally from its position in the periodic table. Then nature of orbitals. அடுத்தது octet arrangement. An atom with octet arrangement, NS2 NP6 arrangement is very highly stable. Hence, atom with stable and electron form this stable octet arrangement. Thus, atom with stable octet arrangement have a maximum ionization potential. Examples: inert gases. Then, electron affinity. It is the amount of energy that released when the electron is added to the natural atom. It is the amount of energy that is released when an electron is added to the neutral atom. Neutral atom வந்து ஒரு எலக்ட்ரான் வந்து ரிமூவ் ஆகிறதுக்கு ஒரு எனர்ஜி தேவைப்படுது. அதுதான் எலக்ட்ரான் அஃபினிட்டி. செகண்ட் எலக்ட்ரான் அஃபினிட்டி, இட் இஸ் த அமௌண்ட் ஆஃப் எனர்ஜி ரெக்வயர்ட், ஒரு எனர்ஜி required to add one more electron to a mononegative ion in the gaseous state, convert into the dinegative ion. Mononegative ion and dinegative ion ஆகிறதுக்கு ஒரு எலக்ட்ரான் வந்து ஆட் ஆகுது. அந்த ஆட் ஆகிறதுக்கு ஒரு எனர்ஜி தேவைப்படுது. அதை வந்து எலக்ட்ரான் அஃபினிட்டி சொல்றாங்க. Factors affecting the electron affinity. atomic radius. Atomic radius வந்து electronegativity வந்து affect பண்ணுது. As the radius increase, the tendency of the nucleus of the atom to attract additional electrons towards its increase. So large atom have a lesser electron affinity than the smaller atom. Then effective nuclear charge. As the effective nuclear charge increases, the tendency of the nucleus of the atom to attract additional electrons towards its increase. Thus, atom with higher nuclear charge have higher electron affinities. Then third one, electronic configuration, completely filled orbitals, half filled atomic orbitals, and third one, atoms with the electrons one short of number required from the completing their orbitals. First one, completely filled orbital. Atoms have completely filled orbitals resist the additional of extra electrons. This accounts for almost zero electron affinity value of second year group electron element and zero group elements which have the outer electronic configuration is ns2 and ns2p6 respectively. Half-filled atomic orbitals. Atoms with half-filled orbitals have a stable and they also resist the additional of extra electron, and this accounts for a lower electron affinity values is nitrogen and phosphorus, which have the electronic configuration of 2s2p3 and 3s2p3 respectively. Atoms with electrons one short of the number required for completing their orbitals. Such atoms have high electron affinities. Example, halogen, they have ns2p6 configuration. These have a very high tendency to make up one electron to attain a stable noble gas electron configuration. Then electronegativity, the relative ability of a bonded atom in a molecule to attract share the electron pair towards itself is known as electronegativity. Factors affecting the electronegativity: size of the atom. Smaller size of an atom, greater its tendency to attract the bonded pair of electrons towards its, and hence more will be its electronegativity. And second one, number of inner shells. The atoms with more number of inner shells between nucleus and outermost cell will have a less electronegativity. This accounts for decreasing order of electronegativities of halogens. Then spin oxidation state. Spin oxidation state, the element in higher oxidation is because the atoms in higher oxidation state will smaller in size and so will have greater attraction of electrons. Number and nature of the other bonded atoms. Electronegativity of an atom is a property which depends on the nature and number atom bounded to it. This is the reason why electronegativity value of an atom is not constant. Example, the electronegativity of value of phosphorus in PCl3 and that in PF3 are totally different. Ionization energy and electron affinity. Atoms with higher ionization energy and the electron affinity will have higher electronegativity values also. And sixth one, types of hybridization. Then we have to see the second unit of ionic bond. What is ionic bond? Ionic bond is a covalent bond, and ionic bond is that bond which is formed when one or more electron form the valence shell of an atom are completely transferred to the valence shell of the another atom. And thus an ionic bond is established between the two atoms whose electronegativity difference is very high. Thus an ionic bond can also be defined as the electrostatic force of attraction existing between the cation and anion of an ionic compounds. Ionic bonds, general properties of ionic compounds: they are soluble in polar solvent like water. They are not soluble in non-polar solvent like benzene and water. They conduct the electricity in solution and in molten state due to the presence of ions. Then They possess a very high melting and boiling point. They become the ion and held together by strong electrostatic attraction. The ionic crystal have a high value of lattice energy. The ionic solids have very little elasticity. They possess a very high density due to the close packing of ions. Ionic solids are highly hot and brittle. The aqueous solution of ionic compounds undergo ionic reaction very quickly due to the attractive force between the oppositively charged ion. The ionic bond is not different directional and therefore ionic compounds do not exhibit the stereoisomerisms. Then lattice energy. What is the lattice energy? The stability of an ionic crystal is measured in terms of lattice energy. Lattice energy of an ionic crystal is defined as the energy released when 1 mole of gas is cation and 1 mole of the gas is anion, separated from each other by an infinite distance or brought to their equilibrium distance to form 1 mole of the ionic crystals. Explanation: the formation of a one mole of an ionic solid A plus B minus solids form its constituent gaseous ions A plus gas and B minus gas may be represented as A plus gas plus B minus gas gives A plus B minus gas plus energy released. This energy released is called as the lattice energy. Application of lattice energy. With the help of lattice energy, we can estimate electron affinity, proton affinities, and the heat of formation. It is applied in discussion of special properties of fluorine in relation to other halogens. It is applied to account for the stabilities of metal chlorides, hydrides, polyhalides, peroxides, and superoxides. It is applied to in the diversion of crystal field stabilization energy. It is applied to account for the occurrence of high oxidation state of metals in their fluorides and low oxidation state in their iodides. Then Born-Haber cycle, lattice energy. The direct determination of lattice energy of an ionic crystal has been carried out for only a few compounds. In few cases, it is not possible to measure the lattice energies directly. That lattice energy measurement used for the Born-Haber cycle. Born-Haber devised a cyclic process to find the lattice energy. Born-Haber cycle can be explained to take in the formation of sodium chloride from elementary solid sodium and elementary gaseous fluoride. First point, the sodium metal is evaporated to sodium atom N, sodium gas. The energy of sublimation is plus S. The diatomic chlorine gas is dissociated to chlorine atom as Cl gas. The energy of dissociation for Cl2 is plus 2. The sodium atoms are ionized to form a sodium ion plus the ionization energy of sodium atom is plus I. Then the electron obtained from sodium atom are transferred to chlorine atoms to form the negative chloride ion Cl minus. This electron affinity of chlorine atom is E. The lattice energy of sodium chloride is U naught. The heat of formation of the crystal form is element is Q. All these changes can be represented by the Born-Haber cycle. This images, the total energy of the formation of the crystal form in the elementary compounds is given by the equation minus Q is equal to S plus half D plus I minus E minus U naught. U naught is therefore the U naught is equal to Q plus S plus half D plus I minus E. Then the covalent bond definition: chemical bond between the two atoms in which a pair of electrons is shared by both the participating atoms is called a covalent bond. Each of the two combining atoms contribute one electron to the another pair and has equal claim on the shared pair electrons. To explain the concept of covalent bond, we need theories which would answer questions like why covalent bonds are formed, how the electrons are arranged in the space in the molecule, how the sharing of electrons would explain the geometry of the molecules, etc. And development in wave mechanics have led to two theories of chemical bonding. One is valence bond theory (VBT) and molecular orbital theory (MOT). Okay, we have to discuss about the VBT and MOT for next classes. Okay, thank you.